questions so far? Does this stuff make sense so far? No? What part? None of it. Can you explain it back to me? What starts the heartbeat? You don't have to answer. Anybody can answer. SA node. SA node. We call it the pacemaker because it tells what to contract. Atria. Once the SA node fires, it also tells the other node called
Atrioventricular, interventricular, AV node.
AV node. AV node sits at the base of the right atrium. Now the AV node tells what to do.
It goes to the IV bundle.
Yeah, it goes to the IV bundle, tells the ventricles to contract. So it's SA node fires first, atria contract, AV node fires second, ventricles contract. Keep those four things straight, and then you can fill in all the gaps in the details. SA node fires first, atria contract, AV node fires second, telling
So
ventricle.
the boom boom with your heartbeat, the first boom is the atrium, and the second larger boom is the ventricles.
Right, right.
The valve, right?
The what?
The valve.
The valve, yeah.
The valves.
The valve.
That's what makes the noise.
Yeah. But yeah, a lot of people think that boom, 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 boom of heart contraction is actually the atria and the ventricles, but it's the valve slamming shut after they've done their business.
Okay.
Yeah. Yeah.
SA node starts in the atria contract, and then it goes to the
AV is second, and the ventricles contract. Good. SA first, atria contract, AV second, ventricles contract. Did you catch the pattern there? The built-in clues? SA, A, atria, and then of course AV. V stands for ventricles. So as long as you get SA first, then you'll get the atria, AV. V stands for your ventricles, and that's the second part. Trina, does that help a little bit? Okay. From the AV node, all we're doing is taking it down a set of nerves, and the bundle of pith is that group where they're together, right there. And then we're going to branch into a left branch and a right branch, and that's just going to take you down each wall and up. And then once we hit those walls, we're going to get into these little tiny fibers called the Purkinje fibers, and that's where you really zap those muscle cells with neurotransmitter and you tell them to contract. All right, how about questions?
so once it gets up, it contracts.
Yeah, see how, let's watch again. Here it comes, there it goes, and as it's coming to the walls like fire, boom, those muscles contract. Yeah. And at the same time, you might notice something else. Let's watch again. There it comes. Watch this feel. As it's full of blood, you've got a blood-full ventricle. You've got Purkinje fibers firing on muscle cells. It's like the great storm, and then boom, those ventricles contract, and you pump the blood up and out. Other questions? It's key that you feel comfortable with this because I'm going to take this the next step, and that's to the EKG. So you want to feel comfortable in your head saying, SA node fires, atria contract, AV node fires, ventricles contract. And it's just that routine that we're looking at here, because we're going to take that now and slide it on over to the EKG. Ready? Okay. An electrocardiogram is a tracing of the heart's activities, and what we're working with here is SA node fires, atria contract, AV node fires, and ventricles contract. And what you're actually seeing here is an idealized view. This is one cardiac cycle, and what we're looking at is a 0.8-second cycle. Keep in mind that's what the time is for the atria to contract and the ventricles to contract. Together that constitutes one heartbeat. point eight. Not point oh eight, but just point eight. This is on page 42 in your course pack and in the textbook. They start on the top of page 593, and they show you in more detail over on page 596. What you might want to do is label this picture with me, because what we're going to do is we're going to start at the beginning of the cardiac cycle. The very first thing to start a heartbeat is SA node fires. SA node fires, and what does that tell the atria to do? Contract. Okay. Right here before this P wave, you might want to jot down SA node fires. Right there before your P wave, you might want to jot down SA node fires. Alright, this is taking you back to muscle physiology and Bio 210. When a neurotransmitter or a stimulus tells a muscle cell to contract, we change the permeability of that cell. What type of ion rushes into your cell now?
Sodium.
Sodium. Okay. So all my little arrows here are showing sodium ions rushing into our cardiac muscle cells. The process of having sodium rush in creates an event that we call what? Depolarization. Good. Notice those sodium ions carry a pretty hefty positive charge with them. So the internal environment here was originally negatively charged at rest, but through depolarization, what do we do to the internal environment now?
It's more positive.
Makes it positive. So the internal environment becomes more positively charged during depolarization. Now come back over here to your EKG. Do you see a little peak here known as the P wave? That's the influx of your sodium ions creating a depolarization event that's causing that positively charged environment there on the inside of your muscle cells in the heart. What we call this right here with the P wave is atrial depolarization. So somewhere around your P wave, let's label P wave atrial depolarization.
The atria contract.
Not quite yet. Yeah, not quite. We're getting there. You make a good point. That was going to be my next question.
Yes.
That's good.
But then the atria contract.
Yeah. What determines if your muscle cells in the heart actually contract? Reaching threshold. If we have enough sodium ions rush in and we create a positive enough environment, then depolarization takes you to the next step, and that's to have a muscle contraction. Guess what? You can't see it. Guess where the atrial contraction is hiding?
Behind the R wave.
Yeah, behind the QRS wave. That's actually where the atria are contracting. It's hidden behind the QRS wave. So you'll want to jot down here somewhere under your QRS wave, that's where your atria contract. Okay, so atria contract behind the QRS wave. They're hidden. broke down in our previous topic the four main processes of having your heart contract. SA node fires, atria contract. AV node fires, ventricles contract. Notice what we're doing. We just showed where SA node fires. Right before the P wave. The P wave is the influx of those sodium ions creating depolarization. As a result, the atria contract. That happens behind the QRS wave. So if we're following suit here, the next thing on our list is AV node fires. Guess where that takes place?
Right in front of the T?
Comes back this way a
In
little
the
bit.
QRS?
QRS wave, yeah. This QRS wave results from the AV node firing. So right here before you start this QRS wave, you might just want to make a little note that this is where the AV node fires. Right before QRS is where the AV node fires. Go back to our picture again. This time, think about those ventricles. When we look at the myocardium here in the heart, you might recall the myocardium and the atria, pretty pathetic, isn't it? Not very thick, not a whole lot of myocardium in those atria. Look at the amount of myocardium you have down there in those ventricles. That's thick, isn't it? There's a lot more muscle cells, a lot more sodium rushing in. You've got a really hefty depolarization event, and look at the response. Look at this jagged up and then back down. That shows a massive increase in sodium, a big depolarization event. Heck, you got more muscle down there in the ventricles, right? So that's why you see such a big spike for the QRS wave. You're looking at this depolarization in the ventricles. QRS itself is technically ventricular what?
Depolarization.
Depolarization, right. Getting ready to contract, the sodium is rushing in. We're going to reach threshold here. So QRS I would label as ventricular depolarization.
And it takes, and that question, why is QRS way longer, is because it takes longer for sodium to enter or reach threshold and depolarization?
Maybe not necessarily longer, but you've got more muscle involved, so it's a bigger depolarization event in terms of charge.
Okay.
So what do we put in that question, why is the QRS wave so large?
Bigger muscle area, more myocardium, because there is more myocardium in those ventricles. And you're looking at depolarization of more myocardium in the ventricles than you would in the atrium. Does that make sense? No? Sure. The reason you have such a big QRS wave is because you've got more myocardium in the ventricles. It's a bigger depolarization event. More myocardium in the ventricles. It's a bigger depolarization event.
And P was the atrial depolarization, right?
Yes.
Okay. And so, just to make sure, you have P, which is the atrial depolarization. The atrial contraction is behind the QRS.
Exactly.
Alright? And then right in front of the Q is where the AV node fires, right?
Right.
Alright.
And in QRS, you've got ventricle depolarization, right?
Yep, because of all the muscle fibers.
Okay.
You need muscle there.
Sure. So this is a